Channel. In today's video, we are going to be solving the dict part of the Starkling challenge. But briefly before we start, let's check the Cairo book on dictionary. Dictionary is more like mappings or hash tables actually in different programming language like Solidity is like mapping in Solidity, right? Whereby you have like a key value pair, right? You have a key and you have a value. So that's exactly how dictionary works in Cairo, but with some other details, right? So the FAIR 252 dict data type represents a collection of key value pairs where each key is unique. Yes, each key has to be unique and associated with a corresponding value. This type of data structure is known differently across different programming languages such as maps, hash tables, associative arrays, and many others. Like I made mention, like mapping, if you're coming from Solidity background, you should know how mapping works. So for 252 dict type is useful when you want to organize your data in a certain way for which using array and indexing doesn't suffice. Cairo Dictionary also allow the programmer to easily simulate the existence of immutable memory when there is none. So I'm going to be explaining this in detail when we're solving the challenge, right? So the basic use of dictionary is it is normal in other languages when creating a dictionary to define the data type. Yes, you if you're coming from solidity background, when you're using mapping, you have to define the data type of both the key and the value. For instance, let's say you want to map address to uint 252. So you have to like specify the data type address and u 252. But in Cairo, the key type is always fel 252. The key type is always fel 252. So you can't change it. The only type that you have to be explicit to define is the value type, but the key type is always 252. So if you want to write values to a dictionary instance, you use insert 252 and insert the 252, which is the key, and then the value type. This is generic at the moment, but if you want to like um if you want to write your own program, you have to like state it explicitly. And then when you want to read value from the dictionary instance, you have to you just call the get method, impute the key value type, which is fel 252, and then it returns the value type for you. So that's basically how you do it. So let's go back to um so our task for dict 1, it says the fel 252 dict maps a fel 252 to a value of the specified type. In this exercise, you will map a fel 252 key to a value of U32. Your task is to create a fel 252 dict containing three elements of type U to U32. The first element should map the key A, which is of fel 252, right, to the value 1. The second key B to the value 2. And the third should map Bob to the value 3. Make me compile and pass the test. So let's see this now in action. So we have the create dictionary function, which returns fel 252 the value type, it returns it. Now this is creating instance of a dictionary. So you put mute with the name of the variable, and then you have this. Now to do, what we need to do is we need to write to this dict. So we do dict, we are inserting dot insert a to value, so a to value 1, dict insert b to value 2, and then bob to value 3. And then since we want to return them, you have to like write dict to return. So most of the time you can actually check the test case. You can, from the test cases, you can infer what the solution is going to be. As you can see in the test case, test dict, it says dict dot get a, the key is a here, must be equals to 1, first element is not 1, this as well. Let's test. Yes, our code compile. So if we do, maybe if we do not go according to how, I just change according to how the tax us to do, right? I just change this one to 9, and it's supposed to be 2 from the test case. It's going to fail. So let's test it. It's going to fail. Exactly. So according to the test case, this is exactly how it's going to be test. Now let's go to the next task. So the two dictionaries can be used to simulate dynamic array. The value they store can be accessed and modified. Your task is to create a function that multiplies the elements stored at the indexes 0 to n of a dictionary by 10. Okay, multiply 0, the elements stored at these indices, okay, 0 to n. We need to multiply those values by 10. Make me compile and make the test pass. So we have this function, multiply elements by 10. Okay, so our to do is to make the function, we need to create a function that multiplies the elements stored at the indices 0 to n of a dictionary by 10. Okay, so let's check let's check the test. So um function test 3, it starts with the instance of the dict, right? And then is inserting 0, which is the key, and then this is the value 1, key value, and then it calls the multiply element by 10, dict, the values, and then 3. Okay, so assert dict get the value of this equals to 10, get the value of 1 equals to 20, 30. Okay, so this is basically what this is doing. So this is basically what this is doing. Dict zero. So this is the index, right? Index of 0 equals 1. Same here, index of 1 equals 2. Index of 2 equals 3, right? So after running multiply, now after running multiply element by 10, after running this function, what we are supposed to get according to the test is that the first the first um the first value here should be 10, the first value here should be 20, so that's multiplying it by 10, and the first value here should be 30. That's the same, it should be the same with this as well. So 5, get 2, 2 is here, so 5 times 10 is 50, 3, yes, 10 times 10 is 100. So that's basically, so what we basically need to do is take each number in the dictionary, right? Take each number in the dictionary, multiply it by 10, put it back in the same spot, and then multiply it like that, like that. So that's what we are basically going to do. So we are going to continue it, we are going to continue the multiplication until we've done this n times, just as the task has asked us to do, right? So what we are going to start with is, um so currently we have the multiply element function, which takes a ref dict, right? A ref dict, and then the nu size. Now it's taking a mutable reference to our dictionary that maps fel 252 to this value type, to, so n is going to represent the number of elements to process, right? So let's just work on the function body. So we're going to start with the loop. So we just basically need to use a loop to iterate through the indexes, right, and multiply each element. So loop is going to like work it out for us. So let mute I, which is going to be represent the value of the index, sorry, u size equals to, so we're going to initialize this, the counter starting from 0, right? So let's write our loop if I, which is this, which is our counter, if I is greater than or equal to n, right? Break, we want it to stop. If once I is greater than or equal to n, we want it to just stop. Now the loop is going to continue until we've processed n elements. Now let's work on the dictionary operations. So we're going to do, let current value equals to, 1 moment, equals to dict, yes, equals to dict dot, want to get I, the counter, dot into, yes, So we're using dot into because we want to convert the index, right, from u size to fel 252. You know, normally when we want to get a value from the dictionary, we get to use the key. We use the key to get the value, but right now from here our counter is of u size. Now we need to convert it to fel 252 here for it to pass. If we do not convert it, is not going to like the compiler is going to is going to complain. So now let's get the current value and multiply it by 10. We already got the current value, so we need to multiply it by 10 right here. Right, so we're going to do dict dot insert I into right current value, multiply by 10, multiply by 10. Yes. So I've gotten the current value here. Now we want to insert the indices, right? And then current value, the value that is going to be here, multiply it by 10. What else do we need to do? Once we multiply it by 10 here, it's going to store, it's going to be inserted in the dictionary straight up. And what else do we need to do? I think this should work. Okay. We need to increment the counter actually. So going to be I plus equals to 1. So we can move to the next index. Now this should work. Let's compile. Yes, this should work. What is the issue? What is the issue? Okay. Um missing missing semicolon. Missing semicolon. Ow. Ow. There's a semicolon right here. Okay. Lines 11. Lines 11. Okay. I see. I see. This is the issue. All of this was a problem for me. Yes, all of this now is supposed to be in here. Yes. Yeah, it's supposed to be in here. Supposed to be still be inside the loop. Inside the loop. Yeah, this should work now. Yes, our code compiled just fine. Let's move to the next exercise. So exercise 3, dict 3 says custom data structure using dict. Using fel 252 dict instruct. Using fel 252 dict instruct allows us to simulate mutable data structures. In this exercise, we have a struct team where a fel 252 dict maps the name of a player to its level. Okay, so the name of the player to the level, the name of the player is going to be the key and the level is going to be the value, right? And keeps track of the number of player using the method set and get from the fel 252 dict traits. Implement the required functions to interact with the team. Make me compile and pass the test. So we have the team with the member level and then the player count. So we have the implementation right here. You have the implementation, new initialize empty team with 0 player, get level, add level, level up, player count. Okay. So let's start with the initialize team. Let's start with the new function. So we're going to create the empty dictionary and start with the 0 player, right? So according to the structs, we have team, right? We have team level. We want to create empty dictionary, right? Because you can see here, so we're going to creating empty dictionary is going to be default. Can I still, let's check this out. It's going to be, yes, default. So something that's default, yes, that's creating. And then the player count is 0. Player count is 0. This is not supposed to. Player count is 0. So that's done. So need to get level. We need to get level for it to return the level, right? For it to return the level for the given player name. So what we do is let's self.level. We're already like taking in a mutable reference to the struct here. So self.level.get, what are we getting? We are getting the name of the player, right? And then it will return the it's going to return the level for the given player name. Now let's move forward to uh the add player function. So the add player function, we have we want to add player, self.level dot insert. Don't forget, insert is the method we use to insert into the dictionary the name, which is the key, and then the level. Then since we are inserting, we need to increment it. Players, no, not player count. Is it? Oh, yeah. It's player count. Player count plus equals to 1. That works. So level up. What we need to do for the players to level up. So let's create a new variable, current level equals to, we need to get the current level first. Self.level.get name. Yeah, that's then to level up, self.level.insert name, current level plus 1. As simple as that. So the player count, so we're going to do to get the player count, basically self as well player count. That should work just fine. Test should work just fine. Let's see. Did it compile? Oh wow, interesting. What's the issue? Default. Oh. It's supposed to be two semicolons. Yes. Let's test it again. Okay. Okay. Something went wrong. Player count. Player count. Player count. Okay. Yes. So we need to add the asterisk operator to dereference the snapshot of the player count. So we just had this, and that should work just fine. Yes, our code compiled successfully, and this has bring us to the end of the Dict challenge. In the next video, we're going to be solving the modules challenge, right? And we have just modules and Starknet to go. I'm so excited. Thank you.